In this video, we're going to take a look at point clouds in QGIS. So today it's live action, and since when I'm recording this, it's 26 days until the release of QGIS 3.18. And one of the big news about 3.18 is the support for point clouds. But most of us don't have a laser scanner or even a drone. So what can you do? And that is what I want to show you in this video. So I'm going to take a GoPro and I'm going to scan that building over there. And essentially I will take a lot of photos. I will put it on interval. And I'm going to walk around the building, pointing the camera towards it. And I'm going to make sure that the building is the main focus inside the viewfinder. If you don't have a GoPro with a built-in GPS, you can use a smartphone and take pictures manually. When you take photos, try to have a fixed exposure so it doesn't vary depending on the light. And if you can, choose a day like this with overcast and not too bright and not too many shadows. And finally, don't be afraid to take too many photos. You can always throw out the ones that you don't need later. So I'm setting my GoPro on interval with a 1 second interval, and I can be a bit closer, so let's get started. So, back in the office, and this time I'm in another room without sound treatment, so the sound may be a bit different from my usual videos. I have downloaded my photos from the camera. Let's bring them up here, and I can run through them and delete unsharp images and images that are extremely similar to others. I'm not going to do that too much here. Just check the photos so they seem okay. If you have a lot of sky, for instance, that with clouds, that could be a problem for the photogrammetry software. So let's bring up a terminal and move to this folder. And in this folder, there's a lot of photos, and there's also a folder called mask. And with an ffmpeg command, I can iterate over these images. I needed to change the case of this file format since my GoPro has uppercase JPEG and this is Linux. But I will change, with ffmpeg, I will change the brightness and move that 25% up. So the images that I copied to the mask folder will be brighter. I will explain that later, but this command will create these images in this folder a bit brighter. And then you can use any graphics software. I'm using Krita here because I find that works the best here. And just drag in the photo you want to mask, and then you use black, completely black, or as black as it can get, and just mask off any areas you don't want to include, like that, for instance. I'm not going to use this later on. Okay, save it. And to show this, I will just delete all photos except that one. Just cancel that. And now I have my masks, but I need to make them black and white. So, mask. And then I create, see if I have it in memory here. Yep. This is more or less the same type of command as before. It takes from this mask folder where I have my edited mask pictures. I iterate over them and convert the result with a threshold of 5%. Everything that is darker than 5% will be black, and everything that is brighter than 5% will be white, hopefully. And then it will be copied back to one folder up under the same name. So let's just try this. And you may need to experiment with the actual percentage. But here I have a mask with the same name as the image, but with the addition of _mask. And that file name was created with the first ffmpeg command. So this will be included when I upload the images to WebODM, and it will tell WebODM to ignore the black areas in this photo. But I don't think I'm going to need any masks, so I will delete that. Let's see. I've started WebODM. Let me add a project. QGIS point cloud test. And I don't want to type anything else. So I will go to my folder. And it is here you should include the masking photos as well. So I take them all, and it's close to a bowling alley. Just name it like that. And in WebODM you can do a lot of settings. There are some why doesn't they show? There are some quick select options for you if you know roughly what you are going to do. And this is buildings. So I'm going to set it to buildings, but I will also change the camera lens. With this camera, I've found that when I use the ultra wide settings on the GoPro, fisheye helps me, but you need to figure that out for your specific camera. And let's see, if I want to create some higher quality, I can do it here. I'm going to leave it as it is. And you can do a lot more settings here. But for now, I'm leaving it at default. So for this, I actually don't need everything. I don't need the report, orthophoto, or the DEM. I do want it to be georeferenced. So by selecting the DEM in this dialog, it will stop before it produces any elevation models and orthophotos. That will only take extra time. So let's save that and then restart it from meshing. So that took additionally 4 minutes, and this time I get a bit more download options. So the model is still looking the same in the point cloud. Amazing, a lot better than I expected. And as you see, the point cloud, there's no roofs on the buildings, but that is because I was taking photos from the ground level. So there are no roofs in any photos. If you want to get a more upside down look and get the ground more clear in the model, you can put your camera on a pole, like a painter's telescope pole, or for window washing, or even a fishing rod. So just getting the camera up, let's say 4-5 meters above ground, and then tilting it slightly down will help enormously when you are creating point clouds without a drone. This point cloud looks actually pretty good, but I will still clean it up a bit before I read it into QGIS. So this button here lets me download the point cloud. That doesn't quite work. There's some form of error when you try to download it separately. But if you select all assets, where did it go? There you go. You will get all the assets available in one zip file. I'm only interested in the georeferencing point cloud. But if you are going to open this point cloud directly in QGIS, you could use the Entwine point cloud. That is, I believe, a tiled point cloud that is formatted in a way that is directly usable in QGIS. I will be using the LAZ file instead, because I want to process it in other software, and QGIS can read this format as well. So I will extract that one to a point cloud folder, like that, and here it is. Skip renaming, like that, and I don't need drone map anymore. I don't, well, that can be there. To clean it up, I will be using another open source software called CloudCompare. So here I simply drag and drop my point cloud file, and I get a dialog like this. You can tweak the settings in this, but I usually just apply all. Since this point cloud is georeferenced, it has a lot of numbers in the coordinates for the points. And to speed up the handling of this, you can shift the coordinates to a local coordinate system. But don't worry, it's only within CloudCompare. So when you export it again, it will have correct coordinates. So I will accept that, and it will import the 13 million points point cloud. Let's just wait a minute. And here we go. So let me just set a new point of origin, like that. want to clip this. So I select the point cloud and I use the clip tool. And let's see, middle of the road there. I think that's okay. And I want to segment in. So everything inside this area should be segmented like that. And I'll leave the rest. That's fine. Then I can confirm segmentation. That will create 2 point clouds. My original and the new one. So together they form the entire point cloud, but since I'm only interested in this part, I choose to show only that. And since it's georeferenced, I can do measurements. Just have it selected and use this tool, point picking, and length. And I pick a point there and here. So this is 17 meters. And if you want to measure elevation, you can click that point and the ground somewhere, hopefully, like this, and look at the delta Z. So it's 12.5 meters high. Anyway, I can do more. I can decimate the point cloud so it's not that many points. Right now this is 12 million points, but I'll leave it at that. And as I mentioned, it looks really great. This worked way better than I expected. So with that one selected, I save and go to my project folder. And this is clipped cloud.laz and 1 centimeter resolution is probably okay. I can set a custom resolution if I want to. I can use optimal resolution, but that will create a substantially bigger file, I think. So for this, I will keep original resolution. For my use in this case, anything better than 1 centimeter is overkill. So I'll keep it that. So this is the master version of QGIS. The 3.18 version is not yet released when I'm recording this. It's 26 days left until packaging. But let's see, point cloud. In QGIS, you will have support for a new file format, LAZ files. So I can just take this and drop it into QGIS, and now it will start to do something. And if I switch to the folder, point cloud there. You will see another folder has been created that is called EPT clipped cloud. So it's reading the compressed point cloud file, and it is creating a hierarchy and so on. And this is actually the data that QGIS is going to use when it views the point cloud. So here we have it. It's in 2D, but right now I can use this to digitize building footprints, for instance. I could have, well, let's do that. I could have segmented the point cloud, removing ground, like this, for instance, and maybe also a bit of the sky, like that. And let's see, which button was it? Yep, that one. Now I have a new point cloud, and this one, let's decimate it. So it's just one every 1 centimeters. And that is just 4 million points. And save it as clay and walls. Yep, that's fine. And the clipped walls layer, let's add that. It will be calculated. And it will calculate this only once. So the next time you add the same layer, it will be much quicker. So here you have only the selected segment. So now it's easier to use this to digitize the building footprint. Anyway, let's look at 3D. And it is correct UTM zone, so it's projected, need to be projected in 3D. And Control Alt M, open on the wrong screen. And before anything will be shown, I need to set the rendering options for 3D to, let's pick RGB. Like that. And also I need to set the ground level, because right now the points are at I guess 250 meters or something like that. Let me see what ground level is. 247. So I don't want to dock it. I will configure, and in the terrain properties I will type that in 246 and apply it. Right now it's terrain based. I will show you other options later. And now it disappeared, so we need to recenter. There we go. And here we go. There is the point cloud. I'm still not quite convinced that the navigation is as it should be. Right and left feels natural, but up and down is for me reversed. Panning is in Z fixed elevation, and that is also fine. It would be nice to have it pan in the camera orientation as an option, and zooming in and out is the right mouse button. But this is really quick. And as you see, the 1 centimeter point cloud is quite okay. I don't see any problem with it. It will really help if we have a substantial graphics card for this. For the WebODM process, unfortunately, it is only CPU based, so at least for now. So there you won't get any benefits from a graphics card, but for this 3D view, it will be helpful with a decent graphics card. Oops. Okay, different view. So this was terrain based, but there's also walk mode, a first person mode. And then you need to reset it again. And this takes some getting used to. Let's see. You are for this you will be using your gain keys. So the WASD keys, and it will follow your camera direction, and that can be a bit confusing, but once you get a hang of it, it's pretty intuitive to move around a point cloud like this. And you can change elevation up and down, move in and out with the keys. And shift and control will, in combination with the keys, will make it quicker or slower to do this pan, moving around. And there are work being done still on this to make it even more intuitive to move around in the point cloud. But I think that this first person view is actually the more intuitive of the two right now. If I switch back to the terrain-based mode, it will disappear from the screen because it is slightly different in between them, so it doesn't seamlessly switch between them, between the modes. That would also be nice if it could do that. Yeah, but that's it, more or less. You don't need a laser scanner. You don't need a drone. If you have access to a GPS-enabled action camera like a GoPro, you can use that. If you get close to the subject you are scanning, use a wide angle setting on the lens. If you are far away, you can use a more narrow field of view in your camera. Don't change the settings in the camera from the first to the last photo. Keep it the same. That will help. And yeah, if you have a camera without GPS, you can still do all this, but your point cloud will not be georeferenced. There are options in ODM to supply a georeference file, but it takes a bit more work. So I'm really looking forward to what the community will create with this and how you will use QGIS to visualize your point clouds. If you want to share your point clouds with others, you can also use the built-in animation settings, where you create a keyframe like this. and there's the first frame. Then you can add another keyframe, let's say at 5 seconds. Yeah, I guess so. 5 seconds. Let's do it like that. Go to that one. Do that one. Add another keyframe at 10 seconds. And do like that. And then we play it. And you can export this video in frames to a folder. Oh, QGIS crashed. That's the curse of working with the master version. Anyway, you can export your video as frames to a folder, and then you can use video software or even FFmpeg to generate a video from those frames. See you next time.